Hello everyone, in this video we will create an exercise on assembly, which is a low-level language to create smart contracts. The other language to create smart contracts is Solidity, and until now we were using Solidity, and still 99.99% of the time we will use Solidity to create smart contracts. In very rare cases we will need to use assembly. So those rare cases, it's either for security or for efficiency or for the operation itself, because some operations that we want to do can only be done with assembly, and that's why you will see assembly code in some smart contracts. If you see it, don't be scared. And generally smart contracts are not written only with assembly, because assembly is harder to read and write. And when you write a contract, the contract is compiled and later converted into a bytecode. It doesn't matter if you write your contract with Solidity or assembly or with a mix of both. It's converted into a bytecode, and inside this bytecode there are some opcodes. Opcodes are the instructions that you need to follow to achieve the operation that you want to do. If you will use Solidity, you will not be using any opcodes inside your functions. But if you use assembly, then you need to express those instructions as opcodes in your contract. So what I mean by opcodes, you will understand it better when you see the example here. So here is a simple function, and with this function we will return the sum of A with B, isn't it? So if it was Solidity, it would be so simple. You would just say return A plus B, as simple as that. But let's do this with assembly. So to do it with assembly, I need to first use the assembly keyword and open some curly braces, as you can see here. And then I will use a local variable, which is let's see, and I'm making it equal. This is the equality sign. It's a little weird, but that's how it is. I'm making it equal to the add opcode here, and this add is adding number A with B, as simple as that. And later, if I want to return C, I cannot just say return C, because assembly, as we have talked, is harder to read and write compared to Solidity. So to do it, I need to do something like this. So first I need to save the value of C at the position of 0 in the memory, and this 0 is expressed in hexadecimal. That's why you see 0x0, because it's 0, in hexadecimal it's 0. And later I can return it by first expressing where is the value and what is the length. The length here is 0.20. 0x20 is hexadecimal again. It means 32 bytes, and this is the maximum length for a number. So that's how it is. And now let's save it and let's deploy it. And now if I add the numbers, let's say 9,5, it should return me 14. Yes, 14. So that's how you do a simple math operation by using assembly. As you can see, it's much more complicated than basically saying return A plus B. If it was Solidity, we would just say this, isn't it? But with assembly we need to use add opcode, and then this mstore opcode, and then this return opcode. So that's like an introduction to assembly, and see you next time. Bye bye.